Hi everyone and welcome. My name is Billy and today I'm just going to present a short introduction and review of some of the ideas that we use in probability. The first thing to remember is that all probabilities lie between 0 and 1. A probability can equal 0 and it can also equal 1. Now it cannot be negative and it cannot be greater than 1. So if you're doing a calculation and you get a negative answer, or you get an answer that's bigger than 1, then you'll probably need to go back and review that question. An easy way to work out what the probability of something is, let's say the probability of A, is to think of the number of times that A occurs over the total number of times. In slightly more formal language, the numerator is the number of favorable outcomes and the denominator is the total number of outcomes. Today I'm going to discuss two concepts in probability. The first one is something called theoretical probability, and the second one is something that's called experimental probability. In theoretical probability, we know what the outcomes are. Here's an example. Let's say I toss a fair die. The sample space for this would be a 1, 2, 3, 4, 5, and 6. Let me define event A, and event A is going to be the even numbers. And now I'm going to ask you to find the probability of getting A. So if we look at our definition above, that the probability of A is the number of times A occurs. So that means the number of even numbers that I have. Let's circle those in blue. 1, 2, 3. So I have 3 on the top, and on the bottom it's just the total number of outcomes, and that is 6. And this simplifies down to 1 over 2. Theoretical probability is exact, and that means we will leave our answers as a fraction. Let's take a look at experimental probability now. So I'm going to do something pretty similar. I'm going to toss a fair die, but this time I'm going to say that I'll toss it 10 times. And I'm going to record the number on the top face. So let's just put here the top face. And I know the possible outcomes are 1, 2, 3, 4, 5, and 6. I'm also going to record the number of times each of these numbers shows on the top face. So let's say number 1 didn't show any times, so 0 times. Number 2, 1 time. Number 3, 4 times. Number 4, 2 times. Number 5, 2 times. And number 6, once. Let me just move this up a little bit. Now the total number of times should be 10 because I define this experiment as tossing a fair die 10 times. So this should add up to 10, and it does. Now, if I ask you for the probability that you get a 4, again, using our definition up here, it's going to be the number of times that 4 occurs over the total number of times. So let's go down here. The number of times a 4 occurs is here, 2. The total number of times is 10. So this answer is 2 on the top over 10 on the bottom, and this simplifies to 1 over 5. Experimental probability is not exact, so you can report your answer as a decimal if you like. Let's just recap the difference between theoretical and experimental probability. In theoretical probability, you know exactly what all the outcomes are going to be. In experimental probability, you do know what those outcomes are as well. But because you've conducted an experiment, you also know the number of times that each of those outcomes occurs. The next thing I want to look at is something called complementary events. A complementary event is simply the not of the event. For example, if you have an event A and you say, I'm going to eat pizza for dinner tonight, then the complement of A, which is written like this, an A with a C, an A with a dash, or an A with a bar across the top. Any one of these, depending on what textbook you have. So A complement is that you do not eat pizza. Now, the probability of eating pizza plus the probability of not eating pizza always adds up to 1. And so you can manipulate this a little bit. If you want to find the probability of some complementary event, it simply becomes 1 minus the probability of that event. So this is an important and quite easy formula to remember. In this video, we've looked at some concepts of probability. The first one is that probability needs to lie between 0 and 1. We also have a very intuitive way of calculating probability, and that is to think of it as it being equal to the number of times that the thing that you are interested in occurs over the total number of possible outcomes or the total number of times that you have conducted an experiment. We've also taken a look at experimental and theoretical probability with a simple example for how to calculate each, and the last thing we looked at was complementary events. I hope this short introductory video has been helpful for you. Thank you for stopping by and watching. See you next time, and bye for now.